Hello everybody, my name is Krishna.Kishore and today let's discuss how can we manage the data stored inside the container in the Docker. So what does this mean is when we run an application inside the container, either the container or the application generates some data or log files or some other files. And we need this data or the files for the future purpose for some analysis, reporting, troubleshooting, so on and so forth. So we are okay with it until the container is up and running. But what if the container goes down? So we know that the data inside the container would be flushed off or vanish when the container is being killed off or terminated by others. But we need this data or the files for certain period of time, days or months. How can we achieve this with the Docker? We can achieve this with the Docker by two means. One is volumes and another one is BindMount. Okay, in volumes, how does this happen is that we first create volume, and wherever the container is writing the data in whichever path, and if we think that the data or the files at that path is required for the future purpose, so what we do is that we attach that path of the container to the volume. Let's say if the created volume name is myvol1, so we attach that to the path. Let's say the path is var lib mysql or SQL. So when we attach this, when we if this container is being killed off or being replaced by the another container, we will still have the data lying at this path in this volume. So this volume then can be attached to the another container and can continue the routine. So at the end, the data or the files won't be lost and would be persist for the future purpose and would continue the service. So we will have the resilience in the service and will not lose the data. How this happens in the BindMount is, instead of so the volumes and BindMount works in a very similar way. The only difference is that instead of creating a volume, we create a path in host machine or in the base machine, okay, and we attach this base machine path to the container path. So let's say if the base machine's path is var lib SQL and the container path is var lib SQL. Likewise, so whenever the container in this case is being killed off or being replaced by the another container, whatever the data is being lying in this path, in the container path var lib SQL, would be persist in the base machine's var lib SQL. So there will be resilience in the service and the data won't be lost when the container is being killed off. Okay, so we will see when we will have to choose volumes and when we can choose BindMount. So we choose them based on our requirement. Now, if you ask me, Kishore, can you give me some real-time examples of usage of the volumes? Yes, of course. Yeah. So I have a few examples being jotted out for you guys. One of the real-time example is persisting database data, like the natural path where the SQL generates the data is var lib SQL. So the question is, we need to safeguard the protect the data at this path from the container. So what do? We create either the volume or the BindMount based on our requirement as we just discussed above, and we will have the data protected. Okay, so although the SQL server or the MySQL is being terminated, we will still have the data being saved over here, and when the new container comes up, the old data can be reused by the new container and can continue the routine. One another example is that sharing files between host and container. Okay, so for some reason, if the user wanted to maintain the data in the container from host machine, we do this, right? So what do we do is that, so one example is that, let's say if you have the nginx being set up at this path, user, I mean, if you have the nginx being set up, so the path where the nginx is writing the data or the configurational path is here. Let's assume this. And if you think that you wanted to manage this data through the host machine, so what we do is that we create the bind mount. Yeah, we create the bind mount at the specific path in the host machine, and we attach this specific path to the container path. The container path is user share nginx HTML, and likewise the base machine's path can be user nginx HTML. Okay, and remember that if whatever the data is being changed or altered in the base machine's path will be reflected in the container and vice versa. So whatever the data is being altered at this part in the container will be reflecting in the base machine as well. One another example is upgrade of the versions. Okay, let's say if you have set up the PostgreSQL inside the container and you would like to upgrade the version of the Postgre, right? So what do? You set up a container 1 with the PostgreSQL with some version, and you create another container, and you create another container with the upgraded version of the PostgreSQL, right? So likewise, you create a volume at the path, let's say varlib PostgreSQL data, and you attach this to a volume, let's say my vol 1. Yeah, and you create another container, and you attach this my vol 1 to that container. So that means whatever the data is being generated by the container 1 at this path will be attached to the container 2 at this path. So we'll see the real-time examples, okay, how to create the volume, how to create the bind mount in a while. Okay, so let's switch to the terminal, and so what do we do over here? Okay, so what we do is that, so our task is that we create volume, okay, and we set up Jenkins in a container, and we create job in the Jenkins, some job in the Jenkins, okay, and then we create container 2 and attach the same volume, let's say my vol 1 to container 2. So what is our motive or objective is that we should see the sample Jenkins job which we created above in Jenkins created by container 2. Okay, so whatever the sample Jenkins job we will be creating in this Jenkins launched from the container 1 should be able to see in the Jenkins created by the container 2. Why does this happen? Because we are attaching the same volume. We are attaching the same volume to both the container 1 and the container 2. So when we launch the container 1, we will create the job over here. Okay, so let's see this in practice. Okay, so how to list down the volumes is docker volume ls. Yeah, so these are some dummy volumes which we can ignore. So as we just discussed, so let's first create volumes. So docker volume create, let's give the name as my vol 1. Okay, and then let's create a container 1 with Jenkins being set up. So docker run in the detached mode, the name of the container, let's say my Jenkins 1, and we attach the volume. We attach the above created volume at this path. At this path where the Jenkins writes the data, where Jenkins home, and we attach or forward the port such that we launch this Jenkins on our browser. and for APIs it is not needed at the moment, but that's fine. And the image name Jenkins LTS slip. Okay, so what are we doing? We create a Jenkins with this name, and we are attaching the myvol1 created over here to this path of the container. So this is the part where the Jenkins writes its data, and we are doing the port forward the base machines port 8080 to the container port 8080, such that we can launch the Jenkins on our local browser. Okay, so it is creating a container. Okay, so the container has been created. Now let's launch the container, the Jenkins. So localhost at port 8080, right? So we would require the initial password. So let's list the logs, docker container logs, the container name, my Jenkins1. Okay, so this is the initial password which we will be requiring over here. Okay, so it is asking the initial password. I'll paste the initial password which I got it from the logs, and let's install some plugins. Okay, we don't need any plugins for this demo at least. Install. Right, it's done. Let's create the dummy user, key my admin, and save and continue. That's it. So we'll be launching the application in the localhost 8080. So it's done. Jenkins is ready to launch. Okay, so when it is launched, so what we said is that next step is to create a Jenkins job, the sample job. Okay, let's create a, let's say job. Okay, under container1. Okay, it's container1, the freestyle one. Okay, so we have created a job. Let's give some shell to execute. Let's say executing in Jenkins launched from container1, just for our understanding. Save. Okay, if needed we can run this as well. And then okay, so it is successful. So the next job is to create the container 2, attach the same volume to the container 2, and then we should be able to see the job which we just created in the container 2. Okay, so let's switch to the terminal. Let's clear the screen. Let's create a container 2. Container 2, okay, the same volume, myvol1, with the same path. But let's change the port, run. Okay, so what did we just do? We have created container 2, my Jenkins 2, and we have attached the same volume which we created some time ago to this path of the container 2, and we are doing the port forward the base machines 8081 to the container port 8080. At this port in the container the Jenkins is running. Okay, so now we'll launch this Jenkins running in the container 2 at the port number 8081. Let's do that. 8081. So we should not be seeing the steps to create the plugin, so on and so forth. See, so it did not ask me to supply the initial password, which we did in this case, yeah, which we did in this case, and it did not ask me to set up some plugins, etc. It directly asked me to log in into it. So the user which we created in the Jenkins in the container 1 is KKadmin. So I'll supply the same credentials over here. Perfect, right? So we can see the Jenkins job which we have created over here, which is running in the container 1, right? So this way the volumes can be shared between the containers as well. Okay, so now let's try and understand how the bind mount works in our case, right? So what do we do over here is that we create path at host machine, okay, and let's say home my Jenkins home, create bind mount, okay, and we attach this bind mount to the container path. Okay, I'll repeat it for you. So what do we do is that we will be creating a path /home/Jenkins home at the host machine, and we attach this host machine path to the container path. Okay, and we will see whatever the data is being generated over here, whether we can see at this path on the base machine or not. Okay, let's do that. Okay, so let's first create the path, the specific path. Okay, let's create my make directory home and Jenkins home. Okay, okay, so the directory has been created. So we have created a path in the host machine, and let's give the permissions. I'll tell you why we would need this permission. So what are we doing? So we are creating a user and group to this path thing, but that's fine. But the path has been created. Okay, so we can see the my Jenkins home with the user and the group KK. All right. So the next step is to create a. Okay. So the next step is to. So what did we just discuss? So the next step is to create the bind, like the bind mount, and attach this base machine's path to the container path. Okay, so the container has been created. So what did we just do? We are creating a container with the my Jenkins 3 name, and we are attaching the volume. We are attaching the bind mount volume. Okay, so this is the base machine's path which we just created, and this is the container path. And in this path, usually the Jenkins writes its data. So now let's launch this application by on the browser at the port number 9191. Okay, so localhost at the path 9191. Okay, it will generate some data. So our intention is to generate some data. So I believe the data has been generated by the container and has been written at this path. So the objective of this function is to check whether the data or the files which been generated at this path in the container is being synced to this path at the host machine. So let's see it. See, so we have all this data which is being generated by the Jenkins written to the container path where Jenkins home. So now whatever I change over here would reflect over here in the container and vice versa. So this is practical way how we can use the bind mount as well. Okay, and I promise to tell you the difference between Docker volume and bind mount right? So when we should use volume and when we should use bind mount is firstly management. In the case of volume, the volumes are being managed by Docker, and in the case of bind mount, it is being managed by host machine, because we are creating the path in the host machine and it is completely separate, not a part of Docker. And another difference is location. So the volume, as we are creating the volume through the Docker, it is being stored as a part of the Docker storage area. And in the case of Docker storage area, and in the case of bind mount, it is the host machine, because we are creating the specific path at the host machine and it is completely under the control of user only. And then use case. So we use volume for best persistence and portability and portability. And we use the bind mount when we need to share the data between the host machine and the container. Yeah, between host machine and container. One another difference is backup and restore. Backup or restore. So the backup and the restore, in terms of volumes, it's very easy, but in terms of bind mount, it is little difficult. Why? Because we are creating the volume inside the Docker storage area. It is little easy when compared to the bind mount. And one other difference is isolation. In terms of volumes, as the volumes is part of the Docker storage area, it is not tied up to the host machine, not tied up to the host machine. But in terms of bind mount, it is being tied up to the host machine and it is a part of host machine. Therefore, this is all about how we can manage the data in the Docker. So there are two mechanisms, volumes and the bind mount. Hope you had learned something in this video and you loved it. I'll come with another session in the next video. Until then, take care. Bye.